Okay, so in number 7, we want to find the limit as x approaches negative 3 of g of x and discuss the continuity of g at x equals negative 3. All right, well, let's just kind of get a picture in our head of what's going on here with this function. This top part right here, hopefully you recognize that the top will factor, and it will factor into x minus 4 times x plus 3, and then conveniently those x plus 3's cancel. So we're going to have a hole in this graph at x equals negative 3. So it's the graph of y equals x minus 4, which is a straight line, but it's going to have a hole at x equals negative 3. But then it's saying, well, if x equals negative 3, then there's going to be a dot, or the value of the function is negative 5. So kind of the big question is the y value of that hole at negative 5, or is that dot going to be somewhere other than where that hole is? So let's think about it in terms of the limit as x approaches negative 3. And the limit is as x approaches negative 3 is as x gets closer and closer and closer to negative 3, what is that y value approaching? So this g of x equals x minus 4 is valid everywhere except x equals negative 3. But as we're getting closer and closer and closer to x equals negative 3, I'm still going to be at x, the equation of the line is still x minus 4. So as I'm getting closer to x equals negative 3, my y value is going to approach 1. I'm sorry, negative 7, because negative 3 minus 4 is negative 7. And that's the y value of that hole. If you cross off your factors, cancel off your factors, and then plug in that x value of the hole, that will give you the y value of the hole, and that's the limit. The limit as x approaches negative 3 of g of x is negative 7. And we know we have a hole there because we canceled it. Now, the other part of this graph is that if x equals negative 3, the y value is negative 5. So I'm going to have a graph with a hole in it and then a dot at negative 3 comma negative 5. So this function is not continuous. Because the value of the function does not equal the value of the limit, which we just said that the limit as x approaches negative 3 of g of x was negative 7, and that does not equal g of negative 3, which equals negative 5. So that's why it's not continuous. All right, on number 8, we have another piecewise function. However, this time I just want to know the limits from as x approaches 1 from the left and as x approaches 1 from the right. Now, if you wanted to, you could graph this piecewise function, but you don't have to, because the limit as x approaches 1 from the left means that I'm going to plug 1 into the equation where the x values are to the left of 1. And that's going to be this top one, because that's where x is less than 1. So if I plug a 1 into 1 plus x squared, I'm going to get 2. And then the limit as x approaches 1 from the right is, I'm going to use the equation where the x values are to the right of 1. So if I plug 1 into 4 minus x, then I get 3. And then the limit as x approaches 1 of f of x does not exist, because the left and the right limits are different. All right, number 9, is f of x continuous at x equals 1? Show the analysis that leads to your conclusion. Okay, that's where we've got to go through our 3 things. So the first part talks about the function being defined. So we're talking about at x equals 1, so we need to find out what f of 1 is. Now, once again, I can't just pick whichever one I want, or the easier one, to plug the 1 and 2. I have to figure out which one of these 2 equations is valid at x equals 1, and it's going to be the 2 minus x. So f of 1 is 2 minus 1, and that equals 1. And that seems kind of goofy to write the 2 minus 1, but it communicates to the person that's grading your test that you're using this bottom equation to find f of 1. Because f of 1 you cannot find using the top equation. All right, so f of 1 is defined and it equals 1. The next thing we need to do is find the limit as x approaches 1. And because it's a piecewise function, I'm going to have to find the left and the right limits. So the limit as x approaches 1 from the left, that's going to be where x is smaller than 1, or to the left of 1, so I'm going to use the top equation. So I'm going to plug 1 into e to the x, and I get e to the 1, or e. And you may remember from pre-cal that that is approximately 2.718. And then the limit as x approaches 1 from the right side, I'm going to use the bottom equation. So that's going to equal 2 minus 1, which equals 1. So does the limit as x approach 1 exist? No. So therefore the limit as x approaches 1 of f of x does not exist, and you are more than welcome to write DNE. That's universally stands for does not exist. So since that limit does not exist, f is not continuous at x equals 1. For what value of the constant c is the function f continuous on negative infinity to infinity? So what we have here is a piecewise function, and I have one equation for the graph to the left of 3 and another equation for the graph to the right of x equals 3. And in order for this function to be continuous, graphically what needs to happen is that those two parts need to meet at x equals 3. So when x equals 3, I need for those two parts to meet or have the same y value. So we think of it as when x equals 3, cx plus 1 needs to equal cx squared minus 1. And when x equals 3, this equation would be 3c plus 1 equals 9c minus 1. And I'm going to bring all the c's over to the right side. So I'm going to get 6c, and if I add 1 to both sides, I get equals 2. And then divide both sides by 6, and c equals 1/3. So if c equals 1/3, then that function will be continuous because the left and the right sides are going to have the same limit, or they have the same y value. Just a couple of different ways to think about that. All right, on 11, if the function f is continuous for all real numbers, and if f of x equals x squared minus 7x plus 12 over x minus 4, when x does not equal 4, then f of 4 equals what? Okay, well, first time you read this, you're probably thinking, okay, that's strange. They just told me that x cannot equal 4, but then they want me to find f of 4. Basically, what they're asking you to do is, this is just part of a piecewise function that's given to you, and they want you to complete the piecewise function so that the function is continuous. So hopefully by now you recognize that this is probably going to factor and cancel, and sure enough it does. It factors into x minus 4 times x minus 3. So the x minus 4's cancel, and we're going to have a whole at x equals 4. What this question is asking is, what is the y value of the whole? So once you factor and cancel off the common factors, that y value is plugging the x equals 4 back into your equation after you've canceled. So when you plug in the 4 back into the equation after you cancel, you get 4 minus 3, or 1. And this is also the limit as x approaches 4 of f of x. It's that y value of the whole. So that y value of the whole is completely tied to that limit. So really what this question is asking is what y value will plug up that hole. So the y value that will plug up that hole is 1. When you plug in a 4, you need a 1.
Okay, one-sided limits, I will always let you use your calculator to do that. So grab your calculator, and I just want to make sure that you are okay looking those up in the table. The easiest way to do absolute value is in the catalog. All right, so we're trying to type in the absolute value of x minus 5. Your catalog button is right next to mode. And when you hit your catalog button, it automatically puts you into alpha mode, so you may or may not be in the A's. But if you're not in the A's, then A is the alpha of equals. So all you don't have to hit the alpha button. It's already in alpha mode. But ABS is absolute value. So absolute value of x minus 5 divided by x minus 5. All right, and I want the limit as x approaches 5 from the left. Okay, so I want to start my table at 5. My delta table is 0.01. That's fine. You have to hit enter twice in order for it to actually take. And then I'm going to go to the table. Now, I wanted 5 from the left side. So would that be coming down the table to the undefined or going up the table? Down, right, because from the left side is basically to the left of 5, and the left of 5 would be 4.98, 4.99, etc. So the left limit is -1. Does the limit as x approach 5 exist? No. The left limit is -1. The right limit is +1. Okay, try B. The square root button's in a different spot. I always have trouble finding it. Good. It's above the times button. Oh, that works too. Okay, this one's a little different. Okay, so coming from the right would be going from the bottom of the table up to the undefined. I've got really big skips in those numbers. Like I'm going from 9 to 11 and then to 15. So what do you think I would go to next? Infinity. Very good. It will be even more obvious if you go back to your table set and start again at 5, but make your delta table 0.001. Then notice that you're going from 25 to 28, 35, 50. The smaller that increment, the bigger the jump in the y values. So very good. It is going to infinity.